Section 20.2, we're going to dive into electricity here and kind of talk about the differences in electricity and when we study electricity, what are the different things that we talk about. So when we study electricity, we're going to talk about three things, and the first one is current. Current is how fast the electric charge is moving through a circuit or through a wire or anything. The unit for current is an amp, and that is key. So the unit for current is an amp. And current is really just how fast the charge wants to move. So our unit is an amp or an ampere. Now there are two types of current, and in class we're going to watch a video on kind of the importance between the two. There's direct current, charge that flows in one direction like a flashlight, and there's alternating current, which the flow of electric charges regularly reverses direction. So it goes positive, negative, positive, negative, positive, negative, where direct current consistently follows one path all the way through. So current is essentially how fast or the path that charge follows. That's probably the best way to describe current is the path that charge follows. All right, which can be direct or alternative, and its unit is an amp. Next up, we have resistance. The best way to define resistance is essentially electrical friction. Imagine you have charge trying to travel down a wire. That's just like traveling down a tube. Anytime you come in contact with the sides of the tube, it's going to slow you down. That is resistance. So resistance is electrical friction. The unit for electrical resistance is an ohm. It's abbreviated like with a upside down horseshoe a little bit. A material can change the resistance. Its thickness, its length, its temperature, all can affect resistance. Think about if you're trying to run through a tube. If that tube was made of molasses or had molasses or like on the outside, or if that tube was like a slide. All right, which one are you going to go down faster? Well, you're going to stick to the molasses and have a little more resistance, where the slide, the plastic slide, you're going to go right through. So that is resistance. Resistance is kind of electrical friction. It's the resistance electricity feels. This can produce heat when you have a lot of resistance, and its unit is an ohm. Next up, the third of the trifecta, the one that you are probably most familiar with, voltage. Charge will only flow if it's connected in a loop. Right? Voltage is the potential difference in the loop. So voltage is the electrical potential energy. We talked about potential energy earlier in the year. That's kind of the stored energy. Voltage is really stored electrical energy. The unit for volts, can't screw this one up. The unit for voltage is volts. Now, one thing that we talk about is high volts doesn't necessarily kill you. It's typically the current that will kill you. How fast that charge is going through your body, not necessarily how much charge is going through your body. So something to kind of keep in mind. So voltage is measured in volts, and it is stored potential energy. How much energy can that electrical circuit produce? And that would be an example of a battery. So we've talked about current, we've talked about resistance, we've talked about voltage. What we can do is we can combine them together in Ohm's law. And what he did is he said the following is true. Voltage is equal to current times resistance. Voltage is in V, volts. I stands for current. Remember, current is in amps, and R stands for resistance, and the unit for resistance is ohms. All right. If you want to draw a circle real quick for this, to solve, voltage is equal to current times resistance, VIR, VIR. All right, and you can take this equation and you can rearrange it and mathematically solve for a variety of tasks. So you can solve for voltage, you can solve for current, or you can solve for resistance, long as you know the other two. So that is Ohm's law, the ability to connect voltage, current, and resistance all into one equation. That we'll conclude section 20.2. You'll have to do an example problem using the equation and a quiz. Good luck.